Welcome back to this Lightning Network. My name is William Santiago. I've been doing this. I've done this presentation in the past few years, and I've always updated the content of it with the latest in innovation related to Lightning Network and other topics that I've done in the past. But so this one was a refresher to the Lightning Network and to give the community the status of where it is, and also be able to explain it in different ways. So let's get started. We will discuss what is the Lightning Network, the structure of the Lightning Network, why do we even need the Lightning Network, why is there a requirement for it. We're going to look at interesting points to mention, and obviously a very interesting analogy that I just found, or a different way of explaining the innovation at the Lightning Network. Some of the old analogies that I've used in the past, I always want to bring them back. And I'm going to have a reference slide that talks about the client and nodes and the two, the way in which they can interact with each other and how you can set them up and how you can use them, and in which scenarios would you use a client with a node that's local or third parties running it. We're also going to look at Taproot. Taproot is an update of the Bitcoin network. Bitcoin itself is a very conservative network. It needs updates. It's evolving. So just like any software, it needs to be updated. Developers do develop on this network on a continuous basis. They run these on tests, but the commitment of the changes usually happen within years and months sometimes. Not like Windows or Android or Apple updates that happen almost on a daily basis. So we'll talk about some of the aspects around Taproot. And finally, we'll have a small demonstration of the Lightning being used as we speak. It's been 3 years, maybe 2 years, two and a half years since it's been live. So it's actually being used as we speak worldwide. So the Lightning Network is they call it the Bitcoin Lightning Network. It's a decentralized systems whereby transactions are sent over the network of payment channels whose transfers of value occurs off blockchain. So these transactions are happening off blockchain. In the show notes or in the description of the meetup, there's a video that I will be doing on the live webinar that you can watch yourself. It's about 2 years old, but it explains the Lightning Network. So these decentralized transactions happen when you open a payment channel. They call it the off-blockchain transactions that happen there. And we'll explain how that works. The Bitcoin transaction may also occur between untrusted parties and secured by the Bitcoin blockchain. Which happens is you're using the same structure security of the Bitcoin blockchain, but you're transferring these messages through a routing network of participants. So you're not on chain, but it's still using the same security of Bitcoin, the same protocols that we use to secure transactions that we have between governments or banks or financial institutions. Same idea here. So in this analogy, we're going to use the analogy of the abacus. We used it when we were kids to learn math. It's basically a calculator. And the idea here is that the Lightning is composed of nodes connected by payment channels. Now these payment channels are the wires. So one wire is one payment channel. So in the case of this abacus, you have multiple payment channels. The beads represent the bitcoins. So these are the satoshis, or the BTC, the value that's in that channel, right? So all these beads are considered satoshis or bitcoins. So in this specific example, Alice and Bob created a payment channel. So now between them, Alice deposits bitcoins from the blockchain. So this is an on-chain transaction. Now Alice has 10 BTC or satoshis. Let's call that. Let's leave the satoshis. The BTC are very too expensive, or the quantity is the value is much bigger. So in this case, Alice has put 10 satoshis here. So Bob has 0, basically. So in this example, each bead equals a satoshi. There's 10 satoshis that she puts out there, or equivalent to 0.00010 BTC. That's basically, this channel has been opened. But these payment channels have shared characteristics. The first one is a bidirectional characteristic, which basically means that the abacus wire can be moved from left to right, just like those beads can move from left to right. The bitcoins or the satoshis can move from Alice to Bob, and vice versa. Another characteristic is the ownership in the abacus. Beads can be either on the left or the right of the wire. But they cannot be in the middle of the wire, basically. So then the same thing goes here. You cannot have a bead that doesn't have an owner. A Satoshi doesn't have an owner. Either Alice owns a Satoshi or Bob owns a Satoshi at every given point. And the other part is that it's fixed, which means that similar to the way that beads cannot be added or removed from the wire, Alice and Bob can exchange the existing Satoshis or the existing beads between them. When they actually open the channel, but if they want to exchange a larger amount of beads that they have, in other words, or satoshis that they would have in that wire, they would have to literally have an on-chain transaction to put those beads in there, which is costly. We'll talk about that too. So this is how the payment channel looks at the moment. Alice has 8, in this case, 8 beads on her end, and Bob has 2 because Alice just sent 2 beads to Bob. That's fairly simple. That happened in the lightning speed, right? So in the next example, we have Alice now has 8 beads. Bob has 2 beads, as you can see here, and that's their channel, right? But let's say that Bob also has another channel with Carol. And he's got 10 beads on his end, and Carol's at 0, just like he had before, right? Now Alice says, okay, I want to pay Carol via Bob because I don't have a direct channel with Carol. So Alice doesn't have a direct channel with Carol. So in the abacus analogy, Alice wants to send 2 beads to Carol. So she moves 2 beads to Alice Bob. So she moves 2 beads right here, right? And then Bob moves 2 beads on the Bob Carol wire to Carol. And this happens at the same time. And Bob cannot keep those 2 beads and not say, I'm not going to send them to Carol. It's an agreement, right? So it's a contract. So it is important to mention that Bob agrees to participate in this transaction. So he accepts Alice's beads without moving the same number of beads to Carol. So he cannot accept that. He has to actually give the 2 beads to Carol. So this is the idea behind this network. Now, to expand that, we end up with what we call the name called hyper-abacus in this analogy, where you have all these abacus connected via all these imaginary wires that connect all the abacus to each other. So there's several wires, payment channels, let's call them, that may connect to any 2 nodes. So all the nodes in the network are connected one or another by chains or wires or nodes. So they're all connected to each other. And you can have this one connect all the way back to this one as well. You can establish those channels. Moving beads along the wire from one node to another, then it becomes an off-chain transaction. Is very cheap because now I can transfer these beads via these channels to any other channel on another abacus. So it just finds its way to get there, basically. And this happens at the same time. So if I transfer some beads to a channel over here, the whole calculation happens through all these beads, and it happens instantaneously at the same time. So adding or removing beads from the wire or transferring them between wires. So in other words, if you take some of these beads and don't use a different shortcut, you take it out completely, you have to break that wire to take the bead and put it over here, break that wire or create a brand new wire. That's an expensive transaction, right? That's what they call an on-chain transaction. So following the same analogy, as the idea is that the chain reaction of a transfers. So in this example, Alice wants to send a payment to Carol. So Alice sends to Carol. But Bob is the only common denominator in this case. So in this case, Bob has 2 channels to Carol. Different types of setup, right? Different amounts. So they don't share the payment channel. So Alice and Carol doesn't share that. So each share a channel with the omnipresent Bob. Bob is always there, that has enough liquidity to be able to send those beads over to Carol, or if Carol wants to send to Alice, the same idea. So Carol, the recipient, requests payment from Alice via an invoice. So basically, Carol sends Alice an invoice, and that invoice gets paid to using Bob, because that's what Carol's instructing her to do. It doesn't have to be Bob; it could be another intermediary, because this is just for the example purposes. So Alice sends satoshis to Bob. Bob accepts her satoshis on one channel before forwarding the same quantity onward to another channel that Carol shares. So there's no satoshis were added or removed to any channel, but the correct quantity was made quickly, cheaply, and this can happen ahead of time. We won't be sending 50 satoshis to Carol because there's not 50 satoshis over here in these channels. So that can be immediately said, no, that invoice cannot be created. Let's put it that way. The invoice can only be created with the amounts that are out there. So Bob becomes the ultimate routing node. So each node is in the chain needs enough liquidity on the outgoing wires to complete the next step in the chain reaction. So each incoming action causes an equal and opposite outgoing reaction, except for the final receipt, which is Carol. Carol receives that Satoshi. So this means that the super hyper-abacus example that we have here needs to have preloaded with plenty of liquidity or plenty of these beads to make the payments possible. And that's what this Lightning Network is growing more and more. So why did we come up with the Lit one? Well, the reason we came up with the Lightning Network is to transform Bitcoin to an electronic true cash system. Because right now everything is 10 minutes, it takes too long, and if you want to speed that up, you have to depend on a third party, just like we have now with Maestros or Visa, MasterCards, and all these other things. And so it allows an arbitrary amount of transactions that can go in there. You get currency cash properties instead of a store of value. You can also make payments more private, and we'll talk about the Taproot part, but it basically, you don't share all the payments on chain, which means they can't be analyzed that well, like we do with the Bitcoin transactions, where you can see the amounts and the addresses, the pseudonymous part. In these payment channels, there's no such thing as addresses, because you don't know where's Carol, basically. Because now in this simple example, we have Bob, we have Alice and Carol, and those are the 3 parties, so it's easy to determine. But when you have many parties or many participants in this network, it's very difficult to find who's Carol or who's Alice. And this also allows for instant peer-to-peer payment. There's no need to wait for this block confirmation that we talked about. In other words, what Lightning solves, why do we need Lightning? It's for scaling Bitcoin. Bitcoin becomes scalable at this point. So some other interesting points is to keep in mind. The Lightning Network is 100% full reserved, so there's no such thing as debt or inflated supply. You cannot spend more money than you have. It's not debt based, and Lightning can work and implement it in any cryptocurrency. The only thing that it requires is the basic cryptographic primitives. In other words, this works on Litecoin. It's being implemented in Ethereum. They have a different name. It's not called Lightning, but it's the same idea. It's called rollups. So you can have these type of solutions, what they call the layer 2 solutions, on these new blockchain innovations. Another analogy that I've used in the past is called the bar tab analogy. It basically means that a customer ordering drinks at a bar can choose to pay for each drink that he drinks until he's drunk. Same as making a transaction on the blockchain, but that's costly because you have to, tell the bartender, serve me the drink, here's my credit card, or here's my cash, or here's my whatever, and you have to pay for that drink. So that first it's costly, it's delayed, and it's not as fast. It doesn't scale well. if you have to pay for each drink. What you can also do is tell the bartender, okay, here's my credit card. Just make sure you keep a tab for $100. I don't want to drink more than that because I don't want to pay for everybody, all the drinks for everybody in the bar, just for myself, maybe my girlfriend or whatever. And then at that moment, that's one expense for slow transaction, which is the first one, to charge the credit for $100 limit. He keeps it open, and from that point on, it's just as fast as a bartender can serve those drinks. At the end of the night, you tell the bartender, I'm done. Can you also order an Uber, charge an Uber, put it on a card as well, because I'm drunk and I can't drive myself. So you can add those things to it. But at the very end, you have the second transaction, which finalizes or settles the order. Pays the bartender, and you get your Uber and go back home. So it requires an unblocked transaction, the first one, to open the channel, and the second one to close the channel. Now, this is the slide that has references. You have what they call different components of the Lightning Network. You have a client and a node. It's fairly simple. You have also an analysis search engine, which is in the screen, and you'll have this presentation will be online, so you can go ahead and use it as a reference guide. Different mobile wallets. You have the Phoenix mobile wallet, Bitcoin Lightning wallet, Blue Wallet, Spark, Zap wallet, Breeze wallets. All of these wallets are able to interact with the Lightning Network, and it uses the way it has to connect to what they call a full-blown node, Bitcoin node. And these nodes are running all over the world, but you can run your own, so you don't have to trust. It's not like a bank that you're trusting them with your information. It's just that you're trusting them with those transactions, that they're actually happening, basically. You might not want to have them to know those things, or you might don't care. So you can run your own node or trust a third party. And most of these wallets either point to a local node or a node that you control and you've set up, or you can use their own provided nodes that they provide. It's just a matter of making sure that those nodes are up and running, because if they're not running, then you can't participate in the Lightning Network or the Bitcoin network for that matter. So Raspberry Blitz is another Lightning node. There's also that you can run yourself on a Raspberry Pi small computer. The Spark is just an implementation of the graphical user interface of the Lightning Network that you can use as well. There's another guide there, ellenroute.com. The Taproot, which is what I mentioned about this upgrade or update to the Bitcoin blockchain, one of the biggest things that's pertaining to Lightning specifically is a replacement of an old standard called ECDSA. Now, ECDSA is a standard protocol to generate signatures. It's a very secure protocol. It's been used for 20, 30 years. And banks use it all the time. Certificates, domain certificates use them all the time. Email certificates use them all the time. It's a standard of signatures. So when Bitcoin was created, they used that standard. The replacement of this standard, one of the things that it improves is in its scalability. And the name of this replacement is called Schnorr signatures. Schnorr signatures is that version of the ECDSA. It basically, in the case of scalability, it aggregates transactions by having one signature that is a sum of other signatures. So you'll have multiple signatures. You take the sum of all those signatures and you create another signature. So now you don't have to. You can scale better because there's less data. Instead of saying, let's say you have 10 signatures, you have to actually have space for 10 signatures to provide to the network. This way you can just sum them all up, create one signature, and now you have less space. So that's a scalability improvement. Another big one is the improvement that Schnorr signature brings is the privacy. It hides a complex script as a single signature. So what this means is that when you create a multi-signature, Lightning is a 2 of 2. So 2 people put in 2 signatures, and one of them have to, it's two out of two signatures. They both have to sign for the transaction to get done. In the case of more complicated transaction where you have 2 out of 3, so only 2 signatures have to sign, or 3 out of 7, or 4 out of 5. There's a complex, right? Now, in the existing ECDSA, these transactions are noticeable. You can see that it's not a simple transaction. It's a more complicated, it takes more space. So you can see it, you can analyze the blockchain. You say, either it's a Lightning Network transaction or it's some kind of complicated transaction to it. So there's a way in which you can determine, analyze the network. So this improves privacy because it hides all of that complexity. Now you see the same signature for a simple transaction as it is for a more complicated transaction. And that's what I meant about Lightning signatures are 2 out of 2 signatures. One thing that it also brings is the foundation framework. This is a framework in which future improvements will be applied to the Bitcoin blockchain. So this is very important because it allows for a better, instead of years, you can narrow it down, you could have more security. You can do more security on your updates because you're following a framework, which is just like we have frameworks for updating databases online, or updating infrastructures, video infrastructures, or databases infrastructures, or even not smart contract, but distributed databases throughout the internet. You've got some framework for that. There's security framework as well. So Bitcoin needed its own foundation framework. So there is also, that's part of this Taproot BIP 0341. One thing to note, this is an update that comes up also, is the labeling of these addresses. A SegWit native address starts with BC1Q, which is what they're going to call it now, SegWit version 0. It uses the ECDSA signature, so the old type of signature. And then you'll have a new signature. We'll use the SNOR signatures because this allows for backwards compatibility. It has SegWit version 1 as its label, or called, and the address has BC1P. So you will recognize the address as, okay, if it's BC1P, I know that's a SNOR signature. If it is BC1Q, it's a more complicated signature. It's an ECDSA, and it carries more space if it is multi-signature. It's not simple, right? So that's a note for the geeks in the room, basically. Now let's look at the demonstration of this of the Lightning in action. So it's best experienced than explained. So what I'm going to do is just going to start. So this is a website that has it's providing a card, products that is selling. This could be on an iPad at a restaurant. It could be a shop. It could be Koiman. It could be Home Depot, Building Depot. It could be any of these. You have the same idea. When you're ready to buy something, in this case we're buying a blockchain, for example. And I have the Lightning Network running on my phone, and I have it displayed on the screen there, as you can see. And this is a test network, so it's not real. It's not the real Bitcoin, because then I will have a lot of money in my lap, in my wallet. But as you can see here, you see a number 0 BTC under that big number, and that's because that's the on-chain. Remember we talked about on-chain and off-chain. The 0 means there's nothing on on-chain. I've placed everything off-chain on the Lightning Network. I created a channel with a node. It could be Starbucks, but it doesn't have to be Starbucks. Because it doesn't have to be Carol that I'm connected directly. In the case of the example of Alice and Carol and Bob, I could be connected to Bob. So anyway, this is the wallet, and that's my. And then you see the Lightning underneath. You see the Lightning symbol, which has the actual indicating it's on the Lightning channel that I have open. So I'm going to go here to the website, say, okay, I'm going to add this blockchain. It adds to my, it says MBTCs, million BTCs, 0.001, so it's very small. It's probably $6, something like that, US dollars. And it creates the order, or the invoice, let's put it that way, creates an invoice, which it depicts the amount that I'm going to be spending. And it says here's the invoice, basically this long number that you cannot see, but you can obviously scan it. So I'm going to go ahead and scan it with my phone. And as you can see, the phone there is starting to see the my desk, and I'm going to go ahead and scan. It says, hey, there you go. That's the amount. It's to that address, and the description is 1 blockachino, and I say, okay, I'm going to pay for this because this is the right amount. As soon as I hit pay, you'll see the phone. My phone says payment sent, and on the website it says received. That's how fast. It's as fast as the internet. It's as fast as those electrons can go from whether this is in the other side of the world or it's my local vendor where I'm at. That's why we call this the Lightning Network, because of this vast way in which you can transfer value from one individual to another. I hope you enjoyed it. The video also that I'll have on the link for the presentation is very helpful, so if you want to go back to that video, it explains it in a different way. But it's about 5 minutes, it's very easy. So I hope you like the webinar, and stay tuned. There will be more coming in the future. Thank you.